Alright, for the first part of the video homework, let's talk about problem 1. So, problem 1. Okay, the first thing, let's try to draw the function between y and the x. So, according to the condition we have right now, we have the figure of function between y and x as this. So this is x, this is fx, x, yeah. Alright, let's make it easy. This is y, okay. So when x is smaller than 0, y is 2. Oh shit. Y is 2. And when x is larger than 0 and smaller than 1, this is 1, this is 2. Y is 0, right here, 0. And when x is larger than 1 and smaller than 2, y equals minus x plus 1. This is the figure of minus x plus 1. This is 2. This is minus x plus 1. And when x is larger than 2, y equals minus 1. Right here, y equals minus 1. Okay, so right now we have the figure of the function between y and x. Okay, next step. With this figure, we can know the part of the density function of y as this. So we can know that when y is smaller than minus 1, it should be 0. And when y is larger than 2, it should be 1, right? Because in this figure, we can find that y is larger than minus 1 and smaller than 2, right? Okay, this is part of the density function of y. So let's go look at the rest part of it, which is when y in minus 1 and 2. Okay, first let's talk about the condition or the case that y is 0. So according to the function between y and x, when we can know that when y is 0, x is larger than 0 and smaller than 1, right? In this part, when y is 0. Okay. And the probability of y equals 0 should be the probability of x between 0 and 1. So this is according to the with the density function, we can know that like this, right? Okay. So and this is a constant, right? Constant. Next part, let's talk about when y equals minus 1. X should be larger than 2 also. In this figure, we can know that when y is minus 1 and x is larger than 2. Okay. So the probability of y equals minus 1 equals probability of x larger than 2, which is also with the definition of density function. Probability of x larger than 2 equals 1 minus density function of 2. Okay, and next, when y is 2, x should be smaller than 0, and the probability of y equals 2 is probability of x smaller than 0. Okay, that's the pure density function right here. Alright, we have talked about some special point, when y is larger than minus 1 and smaller than 2. So let's talk about the common case when y is in minus 1 and 0. In this part, y equals minus x plus 1. So we know that the relationship between This is the mass function, the mass probability function of y, and the mass probability function of x should be like this. Right, this is the derivative of gx. Okay, and we know that this is, we can take, because from this equation we know that x equals 1 minus y. So we just took 1 minus y to replace x in this function. Okay. And because right here the derivative of gx is minus 1. So with the absolute value, we know that this part is 1. Okay. So then we have the total part, the whole mass probability function of y, which is 1 minus fx2. This is when y equals minus 1, and fx 1 minus y, when y between minus 1 and 0, and when y equals 0, which is fx 1 minus fx 0, and fx 0 when y equals 2. Right? Okay, this is all of it. Yeah. Then from this part, we know that when y equals minus 1 and 0 and 2, the value of the mass function of y, they're all constants. So it makes it easier for us to get the probability density function. So we can know that when minus y smaller than y, minus 1 smaller than y, and smaller than 0, the density function of y should be like this. 1 minus m. Let's use m to replace y. And that's very easy. We just separate it into two parts. The first part, smaller than minus 1, and the next part, larger than minus 1. Then we have 1 minus fx 1 minus y as the answer of it. So we can write down the density function of y here. 0, yeah, we have talked about this before. And what we have got just now, from minus 1 to 0, and right here, 1 minus fx 0. And 1 when y is larger than 2. Also, we have talked about it. So the rest of the things we have to do is drawing. So let's do it. The first part, let's draw the density function because it's close to us right now. Okay. Density function, this is density function, this is y from minus 1. From minus 1, we have the value is 0, so it's like this. Okay. And from minus 1 to 0, it equals 1 minus fx 1 minus y. So it should be like this. No, there should be is larger than 0 and smaller than 2, it's a constant like this from 1 to 2. Okay, and when y is larger than 2, we got 1 right here. Okay. Next, let's draw the mass function of y. Let's go back to C. What does it look like? Right, it looks like this. Only this part is a function, and all other parts, they're all constants. So the only thing we have to do is this. So let's make some point. This is 2. This is -1. And when y is between -1 and 0, we have it like this. Like this. -y. And when y equals 0, there is a value right here. And when y equals 2, there is also a value right here. So, alright, this is the end of the problem 1. So, thank you.